Decided to give you a fourth example, which is about the worst possible index law question imaginable. So in this particular case, we're asked to simplify this horrible looking thing. It's got fractions, it's got some negative powers, it's got a couple of fractional powers actually. It's got a division of two fractions. This one really is going to test you to see whether you really understand how to simplify them. And if you can do this kind of question, you will be fine with whatever we might throw at you in the exam. So as I mentioned in one of the earlier ones, I like to try and simplify things inside the brackets as much as possible, especially when I've got kind of messy powers here, because that's going to limit how many things I have to apply this power to, and therefore it's going to limit the number of mistakes I could potentially make. So I'm going to tidy up in here and tidy up in here first. So my first expression here, I've only got the one constant, so I'll throw these things in the brackets with the -1. I'm going to have my 2 in my denominator there. Let's have a look at the rest there. I've got an x on the top divided by an x cubed. And x divided by x cubed, well, here we've got to subtract the powers. So one way you can think about it is x to the -2. Since I'm going to have this fraction going on anyway, I'm going to actually write this as 1 on x squared. So I'll put the x squared in the denominator there. Either way can work, but when I've got to have a fraction anyway, I figure this is probably the nicer way to go. So here we've got y to the 5 and y on the top and y to the -2 on the bottom. So y to the 5 on y to the -2, well, again, subtract the powers. Y to the 5 minus -2, that's y to the 7, and I'm going to throw that into the numerator. I might just tidy up my fraction there. That'll teach me to write things before I've actually worked out what needs to go there. So let's have a look at this part here. In this particular fraction, we've got a nice bit of cancelling going on here. So I'm going to have a 2 in the numerator, like that. Now, again, look at our x's. This time we've got an x to the power of 8 divided by an x to the half. Now, just because it's a half doesn't mean we can't still do this trick here where we subtract the powers, and that's the best way to go with this. I'm going to have x to the 8 minus 1/2. Now, I know some of you like to write mixed numerals. Try to suppress that and write the answer as an improper fraction. So 8 is the same as 16 on 2, and then 16 minus 1 is 15. So x to the 15 on 2 is going to be the answer there. It looks funny and it looks weird, but it's worth doing because, as we'll see in this particular question and in many questions, you can save yourself a lot of work by writing it like that. So that's that term there. Let's have a look at our y's. We've got a y on the top, and we've got a y to the 4 on the bottom. Again, subtracting the powers, 1 minus 4 is y to the -3. And I'm going to actually write it as 1 on y cubed. I know I can avoid the whole fraction thing here, but I'm going to write it like that because there's a lot of minuses flying around, and if we just try and make everything as positive as possible, it limits our chances of making mistakes with those. So I've tidied up my brackets. Next thing I'm going to do is deal with these powers here. Now, a negative power, we've already said, and we've already seen, inverts a fraction. So this -1, I can get rid of it by just inverting this fraction. So I'm going to end up with 2x squared on y to the 7. This second fraction, I'm just going to leave the division there for the moment. I'm going to tidy this business up here. This is a power on the outside that I need to apply to every term inside. So I'm going to get a 2 to the power of 2/3. I'm going to get an x to the power of 15 on 2 multiplied by 2/3. And I'm going to have a y cubed times 2/3. And here we see why it's a good idea to leave these as improper fractions. Often these questions will be rigged so that things will work nicely here. And in this particular case, my 2's are going to cancel. and my 15 can be divided by 3. And you wouldn't see that if it was a mixed numeral. So that's actually going to be x to the 5 on the top there. And similarly on the bottom, they're going to cancel and I'm going to get a y squared. So after that process, I'll have a 2 to the 2/3 x to the 5 on y squared. And we've basically done the hardest work in this. Kind of untangling all these brackets and fractional powers and stuff is the worst bit. And once we get to something like this, it's relatively easy. Remember when we're dividing two fractions that we change this to a multiplication and flip the second one. So this becomes y squared on 2 to the 2/3 x to the 5. Tidying that up, a y squared on the top and a y to the 7 on the bottom. I'm going to left with y to the 5 on the bottom. I've got an x cubed and an x to the 5. That'll leave me with an x squared and an x to the 5. That's going to leave me with x cubed. So now on the top I've just got a 2. On the bottom I've got a 2 to the 2/3. I've got an x cubed and I've got a y to the 5. Now I can still tidy up this here. And so let's just do it off to the side. I've got a 2 to the 1 divided by 2 to the 2/3. That's the same as 2 to the 1 minus 2/3, or 2 to the power of 1/3. So on the top of this fraction I actually have 2 to the power of 1/3. Divided by x cubed y to the 5. And this is my simplified form of this, this expression.